So, students, in the previous lecture, we have studied about the waterfall model, and in today's lecture, we are going to see how incremental process models help us to overcome the various drawbacks of waterfall models. So, I believe everybody knows about waterfall model, and it is a very sequential process model, very simple stage process model, and it has certain drawbacks like it cannot process anything which goes against the sequence, and secondly, it is it in this the customer has to have certain patience because he cannot see any workable or deployable part of the software until late in that particular software design. So these type of issues actually triggered for another set of process models that is known as incremental process models. In many situations, the initial software requirements are reasonably well defined. So the thing is, now I have well defined set of requirements that I know what I actually want in the complete set of software in that particular piece of software. However, there may be a compelling need to provide a limited set of software functionality to users and then refine and expand on the functionality in the later stage of the software releases. That means but there might be certain set of constraints that I have in maybe related to technology, or maybe related to funding, maybe related to my expertise, and that are compelling me that I cannot give the complete functionality to you as of now. So what I may do is I may release a certain limited set of functionality to you as of now, and then I will refine or expand that particular functionality at some later stages of the software development. In all such cases, it is advisable to use incremental process models. So, this statement which is mentioned here clearly sets a particular line between waterfall model and the incremental process model. The line which is bold out here says that the requirements are reasonably well defined, but they are not stable. Okay, so they may expand, they may change in the due course of time. So when the requirement are stable and well defined, we go for waterfall model. When the requirement are well defined but not reasonably stable, we go with incremental process model. I hope this is clear to all the students the difference between waterfall model and incremental process model. When you are going to choose between the two, you will see these two factors, reasonably stable and well defined requirements. So if they both are true, we go for waterfall model. If the reasonable well defined is true and stability is not true, we go for incremental process model. Now, there are two types of incremental models. One is called the incremental model by the name it goes, and second is the rapid application development, which is known as RAD model. So based on the definition, we have these two type of incremental models. So we will see one by one the difference between these two. So let us begin upon incremental model. So in exam, if I ask incremental process models, so if you see the name itself, you have to define both the model, which are the sub part of the incremental process model. If I if I say that you actually see only incremental model word, so you have to define only one, that is this incremental model. So let us see this diagram, which is a project calendar on the x-axis and software functionality and features on the y-axis. So you see that there are different type of activities are shown by different type of blocks and made in different type of colors. So it says that the first increment might have certain core functionalities. Okay, what is the in the definition it says that I will deliver certain set of limited functionalities, and then I will keep on expanding and refining the set of functionalities. So the first increment, which is the bottom of this particular timeline, It says that I will develop these things. I will deliver from the increment. In the increment one, I will deliver all those functionalities which are required at the earliest, or that are the core of the software development. They are the basis of the next development. Okay, once I've done the important part, now I can start the second increment, and I can just create add-ons. I can create more modules on top of the existing base. The incremental model actually takes the first increment, and this is the core product, and after this core product has been developed, you go for the next stage and do give the second increment. This is the second set of functionalities that a customer requires, and then you go for third increment. Likewise, you can go to another increment for completing the software development process. So when an increment model is used, the first increment is often known as core product. Okay, so this is the first increment, which is known as a core product. The core product addresses the basic requirements. However, supplementary features are undelivered. That means that core product actually has lots of only those set of requirements that are very base, the basic, and because of which the next increment cannot be done. Okay, so in that case, we actually take on all the important like requirements out of set of requirements, and then create the core like a pizza base. Okay, you have a pizza base. If the base is not good, any topping that you put on the base will not be liked by any of the customer. So the base should be very sound and very prepared, very sophisticatedly, and do with very care. So the core product actually has all the basic necessary requirements which is actually required for the further development of the software. This core product is evaluated by the customer. The first increment is always evaluated by the customer till the time customer is evaluating that particular set of requirement. After the delivery of the first increment, customer is evaluating, and by the time I started the development of the second phase also. So if I get any reviews from the customer, I will incorporate all those reviews in the second increment. Okay, so this is the best part, that you can also incorporate the feedback or the reviews of the customer in the second increment, and that then it refines the first increment. The issues that are left in the first increment can be refined in the second increment of that model. The incremental development is particularly useful when the staffing is unavailable for a complete implementation by the business deadline. So if I have less number of people and I want to create a software, I cannot do it with the handful of people. So what I will do, I will divide that project into certain increments so that I can deliver everything on time with the limited set of peoples only. In addition, increments can be planned to manage technical risk. This is the second aspect or perspective. That means I have certain people which actually knows advanced Java, and some of them are intern which actually don't know advanced Java. They are good in core Java. So what I will do, I will take care of these two peoples and align certain set of peoples along with this core team to develop the core product. Till the time they are developing the certain set of initial features, rest of the people may get trained. So I manage the technical risk. Once they are trained, we can go ahead with the second increment and create it much fastly than we have done in the core product. So we manage both these things with the help of incremental model. Now the RAD model, on the other hand, is a fast adaptation of waterfall model. Okay, so it focuses on short development cycles. It says that now if I don't have any limitation on the number of resources that I have, but I'm constrained, then how can I be constrained? I can be constrained with time. So it says that you might have a sufficient amount of resource. You had number of peoples available to you. They are very expert in that particular domain, but you are constrained with the time. So now the customer says, I don't want to give you a time of your choice. I will give you a time of certain set of days in which you need to develop that product. So that what is the philosophy of RAD model. So RAD is an incremental software process model that emphasizes on short development cycles. RAD is a high-speed adaptation of waterfall model in which rapid development is achieved using component-based construction approach. So component means the modules that has been created. So if requirements are well understood but project scope is constrained, RAD approach can develop a fully functional software within time span of 60 to 90 days. That means that requirements are well understood. Okay, they are well understood. They are not stable. They may change, but the thing is, the scope is constrained. That means you have to develop a working construction type of thing within 60 to 90 days. So this is the particular constraint that was I was talking about, that the constraint in time, temporal constraint, which says it's 60 to 90 days you have to develop a complete set of software. So if we see the workflow of like RAD model, it says that there's a communication and planning phase which is out of this constraint. Okay, the constraint only talks about the modeling and the construction part. Okay, the designing and the coding and test should be done in 60 to 90 days. The requirements, engineering and the planning is out of the constraint. Deployment is out of constraint. Okay, window. So the team, what you do is, you once you're done with the communication part and the planning part, you divide that particular work into n number of teams, right? And each teams have to do two piece of activities. One is called modeling, one is called construction. Each team has to do modeling construction independently, and these teams should work independently. Okay, they should not have anything in common. So why I want this, because if team 1 is waiting for team 2 and team 2 is waiting for something on team 3, this dependency will slow down the process and you will miss the constraint of 60 to 90 days. So that's why what I say is, all these teams should work independently. Once they are done with all their work, this using component use, automatic code generation and testing, they will actually give it this the inputs to the deployment. And once you have a deployment manager, it will deploy all these versions of team 1, team 2 and team 3 and create a final deployment for the customer. Okay, so modeling here has three aspects, which is called business modeling, data modeling, and process modeling. We will see when we discuss in third unit about the modeling part. And component reuse generally means, like you, if I say whether have you used a component, most of you say no. But if I say that you might have used, if you work with Python, you might have used import function, that you have imported certain libraries. If you have worked in Java, then you have actually imported certain libraries, even if C++. So what are these libraries? What are these packages? They are the code that has been developed by someone else, right? It's not your code, but you are using it. Why you are using it? There are two reasons. One is the standardization of the structure. That means you want to follow same structure that is followed by everyone else. And second thing is, it cuts down the cost. Okay, it cuts down the time, right? Now you can develop a thing which, if it might have cost you more to develop on your own, you have taken help from someone else, and the code actually works for you. Okay, it's open source, so that's why it is very helpful for component use. Automatic code generation is also there. You can generate the code very easily nowadays using AI and other tools. But there's a drawback for a RAD model. For large but scalable projects, RAD requires sufficient human resource to create a right number of RAD teams. If the project is very, very large, you need to have a huge number of teams, and managing those teams are very, really challenging type of jobs. Okay, building the components for RAD is problematic in case of if in case system cannot be properly modelized. So if you cannot modelize the things, you cannot create independent modules. And independent modules means each team gets own module and is with the least set of dependency. So if you cannot reduce the dependency between the modules, this RAD thing might not actually work. In case of technical risk, is high, RAD may not be appropriate approach. That means if the people involved in that particular RAD process are not experienced enough, because you have a constraint of 90 days, maximum 90 days, you need to have a right set of people working on the problem. Okay, like a trauma center in hospitals, you cannot deploy any doctor in the trauma center. Okay, you need to have only experience and only people with right set of skills be a part of the trauma center. That's why for a RAD model, you need to have people who have the right set of skills and the caliber to work in that particular team. So if you don't have all these things, this RAD model actually will be a very problematic situation. Now, this was all about incremental process models. Next, we will see what is the evolutionary process models. Thank you.